Talk about negative and positive predictive variables. This is slide number 3. Negative predictive variable or APV and positive predictive variable or PPV. Uh, it varies based on the prevalence of the disease in the population. NPV and PPV start with the test. NPV, the question here is, if you don't have a negative test, what do you like who you really don't have the disease? PPV. And the question is, if you don't have a positive test, what is the likelihood you really do have the disease? Then number 3, sensitivity. If you have the disease, what is the likelihood you have the positive test? And number 4, specificity. If you don't have the disease, what is the likelihood you have a negative test? The greater the prevalence of the disease, the greater the PPV. The lesser the prevalence of the disease, the greater the NPV. Let's discuss absolute and relative risk reduction. ARR or absolute risk reduction is the percentage increase of the risk of death and disease from a treatment compared with 100%. Example, every 100 angioplasty procedure performed, one person has major bleeding leading to death. The rate for AR attributed to risk of fatal complication of angioplasty is 1% or 0.01. Uh, it means that every 100 people we treat become one person. AR is 1% or 0.01. Relative risk reduction or RRR only seems to be much larger number. RRR can be used to uh, exaggerate the effectiveness of the medication. For example, patients without heart disease and with high LDL levels, the use of statin medication may reduce mortality, going from 3% mortality to 2% mortality is a reduction of 32%. Let's go to the next slide, which is slide number 10. In this case, we can exaggerate it by saying statin result in a 33% reduction of mortality. Yes, there is a 30%, but only let's talk about standard deviation. Number 1, critical concept for understanding sets of data. Number 2, a must-know fact for the boards. Number 3, SD, 1 SD for standard deviation above the mean in case your score is better than 84% of the expected. The standard deviation of the board is 18 points, for example. You will have to pass 258, it is 240 plus 18 to be better than 84% of the and this is shown on figure 15/2 standard deviation. And when the data is normally distributed, number 1 SD is equal to 68% of the scores. Let's go to the next slide. Slide number 5. Two SDs, this is 90%, 95% of the scores. Three SDs, this is 97.7% of the scores. Following the graphic representation of the vector SD on the grouping of the data around the mean, the tallest line in the graph shows the smallest SD. So when we figure out /3, you see the vector SD on the mean. Let's discuss here SEM, standard error. For what SEM, how tight set of data is. But SEM is the SD divided by the square.
I'm Kiki Palmer.
I'm Kyle.
Welcome to Bear Witness, Take Action.
Number 3,
The third in a series of sessions committed to elevating and enhancing the voice.
it becomes narrow. Then this is more precise. Number 4, lowercase Greek letter C represent SD. Let's go to the next slide. And here we are shown on slide 6 on the top how this works. Z-score. Z-score tells you how far of the goal your score. Number 2, one standard deviation above the mean. It is a Z-score of 1.0. One SD below the mean is also the Z-score of -1. Number 3, two SDs above the mean is Z-score of 2.0. Let's discuss so-called confidence interval. CI or confidence interval assess the precision, the collection of the data. Confidence as SI record what either the data points are centralized around the mean or scattered. Number 3, more scattered means less precision. Number 4, when the CI or confidence interval crosses 1, it means that the results are not significant. The 95% of SI or confidence intervals then is used basically 2 times ACM. ACM is equal to SD divided by the square root of n or the number of measurements. Let's go to the next slide. On figure 15/4, we see so-called confidence intervals. And then and 5 and 10 and 150. The confidence interval and 10 is 95 and 10 is 95 and 150 is again 95. Let's discuss so-called descriptive statistics. Appearing measurements in a set of data points. Example 1, 2, 3, 4, 8, 8, 8, 20, 10. The mode of 8 because of this is the most frequently measured. Mean. The average of all the data points, the data collection. Example 1, 2, 3, 4, 8, 8.